All right, here we go. Our very final example of solving trigonometric equations. This one's going to involve a lot. It's going to involve not only one, but two identities and some factoring, so get ready for this. First thing, as we talked in our last video, if you have something with a sine or cosine of 2 theta, use one of your double angle identities or double angle formulas to begin. And so cosine of 2 theta, recall, was equal to just cosine squared of theta minus sine squared of theta. And so I'll start with that. So plus 3 and then equals 5 cosine theta. Okay, now unfortunately we've now introduced another sine or cosine, like we've introduced sine into this problem. And really we only want to deal with sines or cosines, not both mixed and matched together. And so what I can do though is sine squared can also become something using one of my identities. And looking at our rearranged Pythagorean identities, I see that sine squared is really the same thing just as 1 minus cosine squared. And so even though that seems kind of counterintuitive because I've made the problem much more involved now, everything is just theta and everything is just cosine at this point. So even though we have made the problem more involved, from here it's going to quickly simplify down. And so notice when I did replace sine squared with 1 minus cosine squared, I put it in parentheses. That's very significant because this negative sign out front is going to have to be distributed in just a moment. So make sure you use parentheses around that part. And then I'll go ahead and finish rewriting this out. So plus 3 and then equals 5 cosine theta. Okay, so let's start distributing and see what happens with this. Again, it's going to involve some factoring before we're done, so it's going to involve a little bit of work. So cosine squared of theta minus 1 plus cosine squared of theta. Don't forget to distribute that negative sign, and then plus 3 and again equals 5 cosine theta. Okay, so there's a lot going on here. However, I have cosine squareds being added together. So I've got one there and one there. Well, you might as well just add those together. They're not going to cancel out because they're both positive. But adding them together, just like x squared plus x squared is 2x squared, I'd have 2 cosine squared of theta. And so I can see that this is why the problem is going to involve some factoring. It's got a cosine squared in it. So thinking ahead a little bit then, just to save a little bit of time, because we're going to have to factor, I want this to be equal to 0. So I think what I'll do right away too is let's go ahead and get this 5 cosine theta, and let's subtract that to bring that over to the other side of the equation. So 2 cosine squared theta minus 5 times cosine of theta, and then adding up our like terms, I had a negative 1 plus a 3, so a plus 2 is equal to 0. And so from here is where I'll now want to factor this problem, okay? If you recall from our factoring videos, if you have a hard time factoring, you might want to think of this not with cosines, but just think of it with x's. And so this could be rewritten just temporarily as 2x squared minus 5x plus 2 equals 0. If this helps to factor, then by all means do this. And so since there's a 2 in front and there is no greatest common factor, I'll need to use the box method to factor this. 2x squared, first term, last term, get those in the box first. Multiply those together. Hopefully you guys are really good at box method factoring by this point. I need two numbers that multiply to 4, but still add up to negative 5. And the two numbers that do that would be negative 4 and negative 1. Let's put x's with those. It doesn't matter where they go, but make sure they have x's. And then I'm going to go ahead and look across rows and columns for greatest common factors. So I can pull out a negative 2 there and an x up there. Going up and down the columns, then I can get a 2x and a negative 1. You always want to match the sign closest to it. And so the factors are 2x minus 1 and x minus 2. However, translating that back into trigonometry, back in our main problem, just replace each of the x's with cosines. And so this would become 2 cosine of theta minus 1 instead of 2x minus 1. And then cosine of theta minus 2 equals 0. And so I know this is a long problem, but we're almost done, believe it or not. Since each of these factors are multiplied together to equal 0, I know that one of the two factors itself must be 0. So either 2 times the cosine of theta minus 1 is 0, or cosine of 2, or cosine theta minus 2 is equal to 0. And so I'll want to solve each of these equations. So let's actually start with the part on the right. When I add 2, I get cosine of theta equals 2. And looking in my trig chart, I don't see a 2. In fact, trying to use a calculator and doing the inverse cosine of 2 gets me an error because it's undefined. There is no angle that can get you a cosine of 2. In fact, there's no angle that can get you a cosine of anything bigger than 1 or less than -1. So that is kind of a bust on that side. We don't get any answers over there. However, on the other side, I can add 1 and then divide by 2. And so doing that all together, I would get cosine of theta equals 1/2. And then looking in my trig chart, I see that there is an angle that gets me a cosine of 1/2. And that angle is, I'm going to write on the side over here, that angle is just pi over 3, which may or may not be one of your solutions. Remember, as we've done all along, think of that as a reference angle. And so what I'm looking for then are two quadrants where cosine is positive. Since my ratio is positive, that will occur in quadrant 1. And so that angle right there is going to be just pi over 3. So yes, in fact, then pi over 3 is an answer, not just a reference angle this time. There is one other quadrant, though, where cosine is positive, and that's in quadrant 4 down here. And so adding that reference angle in right there is pi over 3. And then remeasuring counterclockwise from the positive x-axis, I see that I get another solution of 5 pi over 3. And so there are all my solutions, just two of them this time, but there are all my solutions that exist on the interval from 0 to 2 pi.